Hello, so today I'm going to start talking about time series data. So time series data is where the explanatory variable is time. So we're looking at the change of something over time. So it could be sales, it could be temperature, it could be rain, it could be anything, but that variable, that's the response variable, the explanatory variable then is always time. The thing about time series data is that it's quite complex and it can have a lot of extreme fluctuations. So fluctuations, you can think of it as being the sharp up and down we might see in a graph. So why would that happen? So thinking about temperature over a long period of time, obviously temperatures up high in the summer months, down low in the winter months. Sales at a shop, they might be extremely different depending on what day it is. So you think takeaway shops might be far busier on Friday, Saturday and Sunday than what they would be on a Tuesday or Wednesday. So that's what we're talking about when we talk about fluctuations. These are the extreme changes. So when we're looking at time series data, we look for several features. Some of them might be present, some of them may not be there. So one of the things we're looking for is trend. That's really one of the things we are really looking for. So a trend is what's happening over a longer period of time. Why are we interested in this? So that that owner of the shop can start to make guesses about, well, what's going to happen in 2 months' time, 3 months' time. Are our sales increasing? Are our sales decreasing? We're wanting to look at that overall trend. You've probably seen graphs about the change in temperatures over the past 100 years, and we're looking at a trend to see, are they increasing? Are they decreasing? We've also looked for cycles, seasonality. They're the sort of two other big ones we look for. Trend is underlining. Then we look to see if they're cyclical, just say cycles, or seasonality. Then there's a couple of other things that could be happening there. A structural change, if there's possible outliers, or just random fluctuations. So let's talk about trend for a little bit. Trend is sort of looking to see if there's that general upwards or downward movement. So we would want to look and make a trend line to show that overall trend. So you can see on the left-hand side graph there, an increasing trend. We've got those fluctuations happening, so the up, down, the peaks and the troughs. The peaks are the up bits, troughs are the down bits. They're still fluctuating, but underneath it all is that trend line, so that we can start to understand what's happening over a longer term. The one on the right is that decreasing trend. So that time periods, it doesn't have to be over years. We could be looking at weeks or even days. So it just depends what we are wanting to look at and the situation. So another big feature that you could see in a long term time series graph is a cycle. And this is where we see these long-term fluctuations that are longer than yearly or seasonality. Basically a pattern that happens that's greater than 12 months, over a period that's greater than 12 months. So here's an example of sunspots that happen over every approximately 11 years. So the pattern of rise and fall repeats every 11 years. If you look closely, you'll see, okay, here, just after 1900, it's fairly low. It goes up for a little bit, then it comes back down again a bit after 1910. So about 11 years. You can see the pattern repeats again, up and down again. So that's that cycle pattern happens over a long term. It's over a period that's longer than 12 months. So if you see a pattern where it happens over a period of more than 12 months, that's a cycle. Seasonality, this is something that we see quite a bit. So it's a time period that is less than a year, less than 12 months. So if you see any patterns that's less than 12 months, that's a seasonal pattern. Now, we call it seasonality, but it doesn't have to be linked to specifically seasons of the year, like winter, autumn, spring, summer. It can be related to anything, months, weeks, any calendar period, even days. So we're looking at sort of the constant highs and lows. So in the graph here, you can see I've got quarter 1, quarter 2, quarter 3, quarter 4. This is because we can think of the year being divided up into 4 quarters. We've got 12 months in a year, so 3 months in a quarter. And so the first quarter would be January, February, March. Second quarter would be April, May, June, etc., etc. So we can see here that, quarter 1 starts up there, then goes down quarter 2, quarter 3, rebounds a bit, and then go down to quarter 4. Then in this next year, again, it goes a bit down quarter 1, but then it follows this same pattern. It goes down from quarter 1 from quarter 2, like it did here, up from quarter 2 to quarter 3, like it did previously, down from quarter 3 to quarter 4, and then you can see that same pattern. The numbers aren't exactly the same, but it's that pattern that we're looking for. It's that same pattern. It's a seasonal pattern because it's happening the same over each year here. So some of the examples I've put in here is that fast food stores typically would have higher sales on Saturdays and Sundays, and maybe Tuesday and Wednesday lower sales. This seasons could be a month or quarter where certain shops or certain businesses have an increase in demand and then naturally decrease. And this is just because of what's happening. So if you think about, if you're a shop that sells skiing supplies, probably during December and January, you're going to have low sales because here in Australia, that's the summer months. People probably aren't looking for ski gear, but there might be an upwards trending sales a bit later on. So in your May, June, July period when people are thinking about going skiing. And this would be a pattern that they'd see repeated over and over again. So these are patterns that we're looking for, and people have to be aware of when they're making decisions. Now, just to run through it so that we're all aware. So we've got 4 seasons in a year. So we might be thinking about that if we're doing rainfall. What's our rainfall over typical seasons of a year? We've got months, 12 months in a year, quarters. With days, we can think about it whether it's a a shop or a business that's open only 5 days a week, or it could be something that's open 7 days a week. We could be thinking about them either way. Now, structural change is when there's a sudden change in what's happening. So these can be fairly extreme events, it's like significantly extreme events, or they could be some kind of change in circumstances. So if you go from a family of 5 living in a house to then just one person living in the house, there's going to be a significant change in the amount of electricity, data being used in that house. Outliers. Outliers are, what can stand out from the general body of data. So you see here, it's from a few years ago, my internet usage for the month of February. You can see there one day really stands out. That's an outlier. And it might be, some kind of special event or something has happened that day to really kick up why you've got higher usage that day. And somewhat annoyingly, we have these irregular fluctuations or random fluctuations, which we can't really attribute to anything in particular. I might come back to this in our next video.